Intersecting lines. Intersecting lines are those lines that intercept each other at a single point but not at right angles. Therefore, in this case, we cannot find the gradient and the equation of the other line if one of the lines is known unless we don't have at least two known points of the second line given, where one of them may be the intercept of the two lines. Example: the line L1 with equation y equals 3x minus 2 is intercepted at point A, minus 7, 6, by another line L2, which passes through point B, minus 1, 4. Find the equation of the line L2. Solution. First, let's find the gradient of L2 since we have 2 points given. Thus, from the equation of gradient we have the following shown on screen. Where x1 and y1 are the coordinates of the leftmost point, here, of point A, we obtain the gradient m2 of the second line. We have the following shown on screen. Now, we can substitute the coordinates of any known point, for example, of the intercept A. In the equation of L2 we have the following shown on screen. We have the following shown on screen. In this way, the equation of L2 becomes the following shown on screen. Remark: you can multiply both sides of the last equation by 3 and send all terms on the left side. In this way, you obtain the equation of L2 in the form A, x, plus b, y, plus c, equals 0. The same thing can be done with the line L1 as well. In this way, we get rid of fractions in the equations of the system. This is a huge advantage, as the system is solved easier. However, the disadvantage of this method besides the extra time needed to do this transformation consists of the fact that the variable y is not isolated anymore. This may cause problems in identifying the points required. From all we have discussed in this tutorial, we draw 4 important conclusions about the relationship between linear graphs. 1. Parallel lines have the same gradient and no intercepts. Hence, the system of linear equations formed by them has no solution. 2. Perpendicular lines represent a special case of intersecting lines, where the product of the corresponding gradients is -1. 3. If two lines have different gradients m1 and m2, and their product is different from -1, they are simply intersecting. 4. If the coefficients m and constants n of two lines are the same, they overlap. That is all for lesson 14.4.5. To continue this tutorial, please watch 14.4.6, Finding the distance between parallel lines. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.